Good morning, ladies and gentlemen, and welcome to today's webinar, How Enterprise Architecture Supports the Digital Twin of Your Organization. It's my pleasure to welcome you all today. Today's presentation will be given by Mark Langhorst. Mark is a managing consultant and chief technology evangelist at BizDesign. Many of you will be familiar with him. Before we start the webinar, we're going to just run over a few housekeeping sessions and then I'll be handing over to Mark. So if you look at the panel associated with GoToWebinar, you'll see a question and answer section. Please feel free to submit any questions you might have throughout the course of this webinar, and we'll be getting to as many as we can at the end of the session. In addition, this webinar will be recorded. We will be making available to you the recording of this webinar along with the slides and other associated materials for your convenience. Please feel free to use those yourselves or indeed forward on to your colleagues. So with that, I'd like to hand over to Mark Langhorst to take us through today's session. Mark, over to you.
Yes, thank you, Will. Just a bit of introduction about myself so you have an idea who's talking to you. Will already kindly introduced me. I have this dual role within BizDesign as a managing consultant and chief technology evangelist. So I'm both on the side of the consulting and the marketing teams. Here you can find some contact details. Some of you might know my name from the Archimate standard in which I'm deeply involved. This presentation today will show maybe a bit of Archimate, but it's not really Archimate focused. The story of today is really about supporting a digital twin of your organization with enterprise architecture and associated disciplines. BizDesign as a company is also maybe new to you if you haven't followed our webinars before. Or seen other content. We are a software company that supports organizations in designing and realizing business change through our software platform. I'll introduce that at the end of the presentation briefly. But the main idea is we support disciplines like enterprise architecture, business process management, and others with a collaborative software platform. Gartner has rated us as a leader, not just a leader, the leader among leaders in this space of enterprise architecture, as you can see from this Gartner Magic Quadrant. Forrester also ranks us as a leader in this space. So if you're looking for solutions in this world, please think of us. But this is not a commercial for BizDesign. This is really about digital twin and what that concept means and what that can mean for your organization. So this is the agenda for today. I will first introduce the concept of a digital twin, which comes from the world of physical technology, but that can also be applied to organizations, twinning your organization. I'll briefly talk about that, and then the meat of the story is the second bullet point in this slide. It's about the steps to create such a digital twin of your organization. What do you need to do? What's the process for that? And then finally, I will address what next steps you could take with your organization to follow up on this webinar. So first of all, what is a digital twin? The concept has been around for quite a while now, especially in physical technology. And the digital twin, you can define it as a digital representation of some real-world entity or system, some machine, equipment, etc. That representation is enhanced by real-time operational data, say from Internet of Things sensors or other ways of measuring that reality. That is linked to a model of that real-world entity, and that is used for all kinds of advanced analytics. A very common example is predictive maintenance, monitoring some equipment and seeing how it performs, if it has some deviations from the norm, and then deciding to say schedule some kind of maintenance. Resource optimization in various shapes and forms is an example. Flow control in processes, product development, looking at how things perform in reality to inform your R&D department, for example. So these are examples from the physical reality, and there are lots of use cases for that. Aircraft engines nowadays have a digital twin. They are monitored. And they're often just leased by aircraft companies. They're not even owned by them, and the manufacturing company still owns the engine, monitors it live, uses that data to enhance the performance. That's a common example. The one that I've listed here on the slide, Tesla, of course, known for its digital capabilities, it has a digital twin of each car they build. and they can fix those cars over the air. Well, you know about the over-the-air updates, of course, but they can also use that to, well, say, fix a rattle in the door. And this example comes from a white paper by CSC. If you get the slides, you can click on that download link. But that's just one example of physical equipment where you have a digital twin. And there are other examples on this slide. You see the manufacturing in Industry 4.0, all sorts of big machinery that has digital twins. You see smart buildings, smart homes. And you now also see personalized patient models in healthcare. So a digital twin of a person to, for example, predict how certain medication would work out for that specific patient. And we will see many more of these digital twins in physical reality based on the Internet of Things, for example, because that merges this world of physical technology and digital technology. Now, these are the more common use cases that we've seen in the past, but we now see the concept also applied to organizations as such. And this is, well, of course, if you can make a digital twin of anything in the real world, why not of your organization? And Gartner has coined this term digital twin of an organization over the last year or so. But the idea is actually not that new. Enterprise models, architecture models, process models, etc., are already a digital representation of your organization. And if you enrich those with operational data on the enterprise, then you get your digital twin. And that's what the story of today is about, how to do that and what you could use that for. So the digital twin of an organization, it is this digital model of your enterprise with an overlay of real-time data from your operational systems, various kinds of sources that enables these advanced analytics for all sorts of dependency and impact analyses, all sorts of improvements you want to make, and I will give examples later on in the presentation. So you have this maybe layered model of different aspects of your enterprise, all linked together with all kinds of metrics, all kinds of data added to that, and that brings your architecture, your design of the enterprise together with the operations. The data measured from reality is fed back into that model or that stack of models to support decision making, to support improvement of your enterprise, etc. So this helps you align resources in the operational enterprise with the strategic goals of the enterprise. It helps you coordinate efforts across different silos in the enterprise because you have this one view of how things operate. And this really will evolve enterprise architecture into a must-have capability for your digital business because it is at the center of this whole development. So how do you go about creating such a digital twin of your organization? And this is the meat of the story, and I will address all these topics separately, go in more detail there. First of all, of course, you need to create a model of your enterprise, or actually we'll see multiple models linked together. The next step is to add this operational data to these models, and that can be data from all kinds of sources. We'll discuss a few examples, but probably in your specific use case, you'll have other ideas. Then based on that, you can visualize and analyze your enterprise. So you can see what's happening, find issues, and based on that, you can then control and change your enterprise. You can decide what to improve, where to make changes, what maybe future options are, etc. And finally, this digital twin itself also has to evolve. So to implement a kind of, let's call it double loop learning, it's not just about improving your enterprise, but also by looking at your digital twin model and looking at the data you harvest from your enterprise, you can improve that model and you can maybe add more data sources. So we'll discuss briefly also how to close the loop of your model. So let's go to the first step, modeling your enterprise, which is actually the backbone of your digital twin. And in general, using these formalized models have all kinds of advantages. It creates something that's, let's say, better defined than just some pictures. Models as formalized constructs help you analyze things, help you communicate things, so you can use them for all kinds of purposes. And here we just see some aspects that you would definitely need to include in your digital twin. So the strategic direction, the business models of your enterprise, how do you make money, where do you want to go? Of course, if you don't have any direction, then how do you validate whether your model expresses what the needs of the company are? You might want to model your current and desired assets and capabilities at a strategic level. What do we have and what are we able to do? More operationally, you might want to model your organization, the business processes you have, etc. So how does it operate? all the supporting technology, information technology, maybe other technology, supporting all these operations, and maybe also the change initiatives. So your projects and programs or agile work streams, etc., that change the enterprise. They should also be part of that digital model so that you can see where you're going. It's not just a static model, and this is somewhat different from a model of physical reality. Usually, if you have, say, an aircraft engine, that doesn't evolve over time that much. Of course, you might want to do some maintenance, and there might be some changes, but an enterprise evolves a lot. That changes a lot. So that evolution should be part of the digital twin as well. Now, doing this all, you can imagine that might be a lot of work, but what we see in practice is that these models, especially of your current state, are more and more automated. Organizations import data from all sorts of sources like CMDBs or workflow tools or process mining, all sorts of sources that help you generate these models, certainly of your current state. Your future state, of course, that requires the brain cells of the architects and the other designers to give direction, but the current state can be automated more and more because you have all these tools that just harvest data from your operational systems, listen to your network, what applications are running, etc., etc. So that's certainly one thing you should remember. Now, like I briefly introduced, it's usually not a single model, a digital twin of your enterprise. It's not a one monolithic thing. You have different aspects captured in different models, maintained by all kinds of communities. Different disciplines are involved. Say your process models are maintained by different people than your architecture models, but they should be linked together. They should be connected. And by connecting these models, you create this backbone for your digital twin that gives you this line of sight from where you want to go with your enterprise to how it operates in daily reality. So that can be a whole stack of models in various different notations, standards. Of course, standards like Archimate, BPMN, UML, open standards in general are a good idea because as all these open standards go, it gives you all kinds of exchangeability. Archimate has this Archimate exchange format that you could use to exchange models with different people involved, different sources, different tools, etc. Similar standards have similar kinds of exchange formats. So rather than using something proprietary, open standards are really the way to go with these models. And you create a set of models that are interlinked to have this digital twin backbone. And just to give some examples of models, here we see a business model canvas expressing at a high level what the different aspects of the business model of a company are. This is for an insurance company, and we see various different areas that are of interest. The value proposition in the middle, its partners, its customers, its activities, etc. Underneath this is an actual Archimate model. This doesn't look like Archimate if you're familiar with that, but actually all these elements here are expressed in Archimate. So say product management, this activity is actually a capability in an Archimate model. Here we see a different kind of model, a business outcome journey map, as it's called, another Gartner concept, by the way. Actually, what you see here is a value stream of creating value by, in this case, insurance products, where you see the different stages of that, the different goals and outcomes associated with it, value propositions for the individual stages, and the capabilities needed to support these stages. So it's in terms of business architecture, a value stream capability cross-mapping. Graphically different, but again, there's an Archimate model behind this. Related also to what we saw in the previous picture. Here we see a capability map. This actually looks like Archimate notation, but capabilities, what can the organization do? What is it able to do? And this is then related to the previous models as well, of course. Here we see different kinds of models, different notations. We see on the left a business process model in BPMN. On the right, we see a business logic model in DMN, the decision model and notation. And actually, those are linked as well, because in the left model, you see this task, determine claim admissibility, for example. And you see this little yellow icon there. And that means that this is linked to a decision model telling you how to make the decisions on claim admissibility. And that's what you see on the right. So again, a number of elements, a number of languages, number of models in these languages linked together, and this model in turn, this process model on the left in turn is linked to a higher level Archimate model in the stack of models that I just mentioned. So you could drill down from your Archimate model to your process model to your decision model, have it all linked together. Here we see yet another model. Again, this is an Archimate picture, and here we use some color coding to express which data is used in which applications. So this striped colorful picture, it just means that for these different applications, they use different kinds of data. I'll come back to this because this example is used further on when we discuss security and privacy and data classification. So that's step one. You have your model with all these different aspects, and that is also something you could evolve. Of course, you don't need to start with a big bang with a huge big model of everything. You can focus on the essence first, and then gradually extend the model. The next step is to add data to those models, and it can be all kinds of data. And here I've just listed some examples. It could be data on your product portfolio, and I'll have a slide on that. So, how are my different products doing? Could be data on customer experience. Do they like what we offer them? Performance data, all sorts of performance. Could be of your business processes and maybe productivity of different departments or availability of systems, all sorts of things. Project performance, time and budget, value created, all kinds of things you could measure. Cost of resources, the life cycle of your technology, maybe security events, then it gets a bit more real time. IoT data streams, you could link those to your models, maybe to use say the movement of passengers on an airport to detect bottlenecks in the physical world based on the models you have of that physical world, but also in the IT world, bottlenecks in processing, say, check-ins of customers, of passengers based on this, etc. But very importantly, data quality is really of the essence. If you have a data source, please make sure that it is good data. Otherwise, of course, you'll base your models on bad data. You'll get bad decisions based on bad data. And the more you combine data, the more important this gets. Because the combination of data, the quality of the combination of data is as good as the worst quality of the data going in there. So if you have all these kinds of data, if just one of them is not good enough, that might affect your entire model. So rather not add a bad source than let's try this and see what happens. So we've got our model repository with this model in the middle. We add all kinds of data to that. So we enrich our model, and here we just have some examples ranging from contracts to user satisfaction, but it can be all sorts of data. Link that to your models, and then you can base all kinds of views on these models that help you in analyzing the state of affairs. And I'll have some examples of those. And here we have a picture that relates to cost calculation. So we add all kinds of cost drivers to our models. For example, the cost of personnel maintaining applications. That's what you see at the top. The different processes to maintain them, say application management, incident management, etc. You have the licenses of these applications. You have maybe external services you use. You have all the infrastructure that's needed, processing, storage, backup, etc. You can aggregate these costs to your application component. And then in the same model, not shown in this picture, but in the same model, you could also look at who is using these applications, with what intensity, and then distribute the cost again to, say, your business units. So you have a cost calculation model based on the structure of the architecture model, plus the data you get from, well, things like incident management systems. How often do we need to do something with this application? From your contract administration, on licenses, from all these different sources, integrate that, and you get this idea of it's sort of a digital cost twin, you could say. This gives you a precise picture on cost. Now, this is just one example. The same applies, of course, to all kinds of data sources where you can use the structure of your model plus the data you harvest to do all kinds of analyses. Here we see something different. This is about application lifecycle data. Here we see business value, technical value of applications, a very common picture in your application management world, application portfolio management. And these technical and business value metrics will in part be based on operational data. Things like the number of incidents that we saw on the previous slide. That is one of the parameters that goes into this technical value metric. You can also add all kinds of other operational data. This is about, well, just an example from our portal solution. Response times of operational processes and how that works out. And this is actually also about incident management and lead time to solve some issues. Different charts that you can use operationally. What we offer is and what you need for this is really something that supports this high performance data integration. It's not just static data that's refreshed once in a while. If you really want to go to this digital twin in a more operational sense, You need to be able to absorb this operational data that might be near real time, so that you can visualize what's happening there, what's happening in near real time, and deal with that. So that speeds up your decision-making process as well. But you do need the data integration for that. And the examples I gave in the previous slides are relatively low speed, but some might be quite high speed. Say if you use this for manufacturing or for security operations, you might want to speed up this cycle so that you can say, for example, if a security incident happens, you use your model to see how that would propagate, where that might impact, and then take measures in real time to protect that, say, asset that is at risk. So there you also see where the models and the data come together. So that's really the uniqueness of this digital twin concept. It's the combination of the model structure and this live data that gives you these unique insights. Now, then we get to step 3. How do you visualize and analyze this? So we have added all kinds of data to our models, depending on your needs. It might be cost data, it might be risk and security data, it might be all sorts of things. But you should visualize that in ways that the decision makers can really use. And you can think of all kinds of analyses. And I'll have a number of examples. Rather than read out all this list, I'll just show you some example slides with pictures. Here we have a high-level one. This is a business scenario analysis. Actually, the story behind this is that the company here, which is this insurance company again, wants to assess the impact of the advent of cognitive systems, these conversational agents, on their business model. And here we see the outcomes that are, say, on the opposite sides of the scale. Either people will still want to have a real human on the other end of the line, so human interaction is prevailing, or we'll have these conversational agents everywhere. And these are the extreme outcomes, of course, so end result might be in the middle, but this is used to assess the impact of these two opposite outcomes on the different aspects of the business model. And that could then be used to decide on whether or not to invest in this kind of technology. So, for example, say this cost factor over here, we see that if people will still prefer human interaction, that might be relatively costly because having, say, a lot of call center agents is fairly expensive. The risk might be a bit lower than in the case that everybody wants to go to this conversational agent, because, of course, it might be more efficient to automate that, but the technology might not be mature enough. You might run some risks that it goes haywire. You might lose some customers that don't like this notion. So it might not be the let's say the least risky option. So this is a way of, at a high level, assessing your business model. This is the product portfolio I mentioned before, and this is also based on operational data from your sales systems, for example. And here you see the market share and market growth of a product. It's called the growth share matrix, or the BCG matrix for Boston Consulting Group, who invented this thing. And you see your stars and cash cows and dogs and question marks, a common classification of products based on a combination of real data on the products, but also behind this is a model that tells you how are these products realized, what's the architecture behind that. And also, take my cost model example, I could also use my cost model to combine the data from my product portfolio with what these products actually cost. And then you might find that, say, one of these stars is actually really very costly. So you might have a lot of revenue, but there might also be a lot of cost associated with one of these. That's another advantage of integrating your structure and your data. You can also drill down from these products into how they are actually realized. The next example shows a number of scorecards that you could create. Behind this is our actual Archimate models, but here we see several scorecards, and the top one is the most common one, the balanced scorecard that everybody knows, with the financial, customer, internal process, and learning and growth perspectives. And in there you see these ovals. Those are actually Archimate goals, but that doesn't really matter. For each of these goals, we've also added some metrics, like, say, for this competitive premium setting goal, there's a measure market share. That's how we measure that. There's the target value, so we want to have 25% market share. We have the current value, that's in the outcome column, and then maybe an initiative to bridge the gap between target and current outcome. So this is also partially based on, let's say, design time analysis, partially based on operational data like these current outcomes. combining that and setting some direction to improve the outcomes, to change your enterprise, in this case, in various ways to get to where you want to go. Here we see another example, capability analysis with these spiderweb diagrams. Also could partially be based on a combination of operational data and design level data from your enterprise architecture. Here we see something that's really quite interesting. I've done this with some Swiss customer last year, looking at the risks their business capabilities run from the underlying technology. And here we see a picture with the availability of business capabilities based on the aggregate availability of the underlying IT systems. And you see some of these are colored red because their availability is relatively low. It might be, for example, that you need a lot of different applications involved and they all have to be up and running. And then the business level aggregate, that's the interesting measure, not whether each individual application has a high availability. That's the IT metric, and the IT management might look at that, but the business is interested in, can we really serve our customers with these capabilities given the availability of all the underlying systems? So you have to multiply these availabilities in some cases, which might lead to some hotspots, some issues. So here you see again a combination of real data, live data from availability of systems in this case, aggregated through the structure of your architecture to pinpoint where in the business this might hurt. The next one is a customer journey map. Here we see, well, in this case, not such a great customer journey. Customers aren't really very happy. This is a current state for a mobile banking customer journey where customers who want to make a payment have to go through 3 different channels: the mobile banking website, SMS authentication, and maybe even the call center if they want to check whether the payment has been completed. And you see that the customer experiences are not that great. So you can measure what the customers think of this maybe by putting some form on your website or some button where they can just vote or like or whatever. And you see those experiences mapped out in the customer journey. Again, a combination of a model of the journey and the live data from customer feedback, which will then, of course, be an incentive to improve this customer journey. You see all these frowny faces. Customers are not very happy. Something else you could do based on these BPMN models, for example, you could measure the mean processing time and throughput, etc. Do all kinds of process analyses and calculate whether you're doing well or not so well. Find waste in your process. Classical process analysis. Of course, this is nothing revolutionary. This has been done for years, but it is an example of this digital twin concept. You use your models, you add the data to them, and you do the analysis to improve things. So like I said, digital twin of an organization, it's partially new, but lots of it is also common practice. Here we see something operational, an operational IT dashboard with some charts of operational effectiveness. In this case, also some issue management things like closed cases, etc. Customer satisfaction, system error charts, some heat maps of different countries. Here we see another kind of heat map. This is about security and risk analysis that you can use models for to see, well, if this is a vulnerability, what would be the impact if a hacker breaches this security over here? Where would be the impact? What's the potential loss we would have? So there you see on the graph on the right, you see this dimension of probable loss magnitude and loss event frequency, etc. So you can do these calculations, assess where you need to act, especially, of course, if you're in the orange or red parts of that graph. You definitely need to take action. Those are the things that would be prioritized, would be the most important ones. And behind this is a whole model that shows how these risks propagate, which you could even use in an operational way. If something's breached, you could use that model to find, okay, if there's a breach over here, what could this hacker reach? Where could they, where could the impact be? Where do we need to take emergency measures, for example? This is another kind of dashboard. Here we see an application portfolio dashboard, and this is interactive. So if I would, based on my previous analysis of risk, if I would select the very high business risk applications by clicking on the red segment in the bottom left-hand chart, you'll see the dashboard change and select only the very high business risk applications. So I can easily zoom in on those, see various aspects of them, things like cost, technical value, geographical distribution, all sorts of things. You can set up these dashboards quite easily, link them to your data on the one hand, on underlying architecture on the other, and you get these interesting analyses. Here we see that analysis that I showed before of your application portfolio. You can also filter this based on these high-risk applications that I showed before, so that you can zoom in on where actually you need to make some changes. And then in the next slide, I'm using the color coding of this time analysis, as it's called, for tolerate, invest, migrate, and eliminate, the 4 quadrants, to draw a map, a landscape map of my IT landscape. And in this case, this is using on the left-hand side the capabilities that are supported by the applications in the middle. At the top, the different information domains that are supported by them. And then you see the color coding used from the previous analysis that show me, well, okay, I need to, well, the green ones are okay, but the red ones I need to really take care of. They have to be eliminated. The yellow ones might need to be, say, re-platformed. I have to invest in those. So this gives me an overview of where the impact of a change would be, which capabilities would be affected, what data is in these systems that I might want to change. So this is, again, an overview of where the impact of a change might be based on the analysis of these applications. Another kind of analysis, this is about data classification for, say, privacy purposes. So if I classify my data according to, say, in this case, privacy level, you see that the middle one, the middle 3 are colored red because they have a high privacy classification level. You see that in the middle. If I then propagate that to my applications, I can see which applications need to be protected, which users are using those applications. So what do I need to do in terms of security, in terms of access rights, etc. So you can use this, let's say, design time to design this in, but also at runtime, if there's a data breach, what could be affected? So that's the analysis part, and then we get to the controlling and changing your enterprise. Because of course, based on that analysis, you want to do something. This is where the rubber meets the road. This is where you support the decision making, and that's, you could say, at 2 levels. It's directing and controlling your enterprise on a day-to-day basis, but also improving the enterprise. So that's why this is called control and change your enterprise. You do that at these 2 sort of time scales. First of all, this is the same example that I ended with in the previous section. Now we've propagated these data classification attributes, in this case to the application landscape that I had in a previous slide, to show which applications should be protected the most. The red ones are the most critical, and you could use this, for example, to show to regulators that you're compliant with things like GDPR. So now we are using privacy classifications of data, propagate that through the models, show where that impacts, and then even maybe use it operationally to see what would happen if, say, some system is breached. Here we see some other analyses. This is about lifecycle analysis, using the lifecycle of systems. If I take a system offline, what would happen? Well, if there are other systems depending on that, that might not be such a great idea. Here we see these red bars in these life cycles, where, for example, this crystal ball system is connected to this Ramadera system, so the 2 at the bottom. And if I would take Ramadera offline because it goes into maintenance, crystal ball can't operate. So this lifecycle planning can't work. This is more in the planning stage, but operationally you could use the same thing. You could use the same dependencies to trace, oh, if I want to switch that off now because we have a problem, then all these other systems might be affected. And you could do impact of change analysis based on all these charts and zoom in on that. Say, if I want to phase out an expensive application, see what's all connected to it. So it's also a design time impact of change analysis. So this is the change part of the enterprise, not just operational control, but also change and improvement. Or look at my projects. What happens if say, project P428 is delayed? If a Scrum team pushes a feature to the next sprint, I can see from my architecture that I then have certain issues. Here we see that there's a direct conflict between P428 and P473, because apparently, according to this plan, P473 has some dependency. But there's an indirect dependency that we only see in the table on the right, but that's in the architecture behind this. That is that these 2 projects work on the same scope. And if they overlap in time, they may step on each other's toes because, well, working on the same system by two different projects, well, you can imagine that that might not be such a great idea. So again, using the architecture behind all this, combined with operational data, in this case on dates of projects or dates of sprints or whatever, you could use that analysis very fruitfully. And then you can aggregate that, and here we see just sort of a high-level overall development of the application landscape. In this case, using that cost analysis from the beginning to show the cost reduction that's projected or that's already from the past, so that we can see and predict what's going to happen with the cost of our IT. That's just one example. So it's measuring, predicting, showing what happens based on this combination of structure and data. Now, as the fifth step, I also mentioned you have to improve your digital twin as well. It's not just a one-shot exercise, and there are two ways of improving it. First of all, you have to make sure that the models themselves are correct. Are they technically sound? Are they consistent? And do people understand them? But of course, the most important check is, do the models and the data still represent the real world? Of course, the real world changes, so you might need to change your model as well. And you may need to recalibrate based on new kinds of data sources, for example. And that's a second level of improvement. It's adding more data to enrich and enhance your digital twin. You can start with just a few sources, gradually build that up. It's not a one-time exercise. You can evolve the digital twin of your enterprise gradually. And what you can also do is speed up your feedback loop. So this, I had these 5 steps. Of course, that is one big feedback loop, but the faster you go around, the closer you can get to reality. If you do this once a year, you can imagine that at the end of the year, your model that you started with at the beginning might already be quite outdated. So the faster you make that feedback loop, the better it is. Right, reaching some conclusions. Now we can get to some questions. Digital twin of your organization can be very useful, can be a great help in all kinds of scenarios. And I've mentioned a few here. So ranging from aligning with operations with strategy, to continuous optimization of the enterprise, and all sorts of ways in between. Operationally, in detecting issues, maybe security issues, cost issues, all sorts of things. But it ranges really from design time, long-term changes to the direct operational impact on the enterprise, and all sorts of things in between. The shorter your feedback loop is, the better it is, so you can adjust and adapt your model quickly, and also adjust and adapt your enterprise quickly. So, well, as feedback goes, the faster you can go around the loop, the better it is. I also mentioned that it is not a one-shot exercise. It is a journey. Take it gradually, build it up, step by step. Don't think you have to do it all in one go, because that might sound a bit daunting. But it is something that is perfectly feasible if you are already, say, as an architect working on enterprise architecture models, and you might already have this vision. Just add some interesting data, show what comes out of that to management, and they will start asking for more. In my experience, if you show them these kinds of analyses, they will say, oh, if you can do this, please also do that. And that really helps you evolve that digital twin as well. And it is really the enterprise architects that are uniquely positioned for this, because you do need to have this broad knowledge of the enterprise. It is something, well, a model of your entire enterprise, or a stack of models, that requires this broad helicopter view of the enterprise and this expertise in modeling and analysis. So enterprise architects are really uniquely positioned to support this concept. Now, to help you further, we have a DTO readiness check. I'll show the link to that again at my last slide. That helps you identify where you are, what next steps you could take. So you can fill it online. It's a short questionnaire. I think it's 8 questions. It's based on our generic adaptive enterprise maturity model, so it also links into our other assessments. So it's not just a standalone thing. It helps you evolve your enterprise in various aspects. So that might be interesting to look at. I'll get back to this at the end. And of course, well, what we also can help you with is a platform that supports this whole concept, this idea of a multi-dimensional enterprise model or stack of models, supporting all these different capabilities on the left, the different disciplines that we support, ranging from strategic modeling to architecture and process management and data management and governance, etc. Horizon is the name of that overall collaboration platform. Enterprise Studio you might know as a modeling tool to create these models. And this also links into all kinds of data sources you see at the bottom. So Excel files, SQL databases, say if you use ServiceNow as your CMDB, or if you use Technopedia from Flexera, all sorts of data sources you could link. And we have a generic way of linking into those sources as well. So that's something that helps you build up that model. So in that modeling platform, we support all kinds of different types of models and views you might need, ranging from your business context to your business design, different kinds of analyses, the transformation of the enterprise, and the governance. And I've shown various examples of this throughout the presentation. So that's the kind of functionality, the kind of models you could use for that. So the idea of having this one platform, instead of having separate tools for separate types of models, that's quite essential in this whole digital twin concept. Because if you have your models in a whole suite of different tools, then it's much more difficult to create these integrated analyses. As you can imagine, if you do your process models over here, your data models over there, your architecture models over here, that becomes quite more complicated. But we can link to all kinds of outside data sources, so this integration even then might be feasible. Then this is my final slide, repeating that digital twin readiness check link again. We will send you a download link for these slides and the recording tomorrow. There's also a link here to a white paper on how you can create a digital twin using enterprise architecture. That link might be a bit difficult to remember or note down, but you will also get that in the email we'll send out. That concludes my presentation, and that maybe leaves some time for questions. So back to Will. Will, are you there?
Hello, sorry about that. Just had to unmute myself there. Mark, thanks once again for a fantastic presentation. To remind everyone again, we'll be sending out to all those people who attended and people who didn't attend the session a link where you will be able to view the recording of this webinar, download the slides, access the digital twin assessment that Mark referenced in this presentation, along with the white paper as well that he referenced. So don't worry about writing down these links. You will be receiving an email probably in the next 24 hours that covers all of these links. So we have a few interesting questions that have come in. Mark, I'm going to ask them for you. Anyone else who would like to ask a question, please submit that via the question and answer panel on the GoToWebinar application. And the first, Mark, is quite a simple question, which I think is great, which is how is this different from good old-fashioned enterprise architecture?
Yeah, actually, you could say it's not that much different. I would say the main difference is the combination of architecture models and maybe other models with operational data. Until recently, we did not really have that, let's say, the technology that you could easily integrate, and we didn't have the richness of operational data sources either. So that combination of architecture models, other models, and data, that is the relatively new part. But more advanced enterprise architects have been doing that for a while. It's more than just creating models of your current and future state. It is really enriching these models with all kinds of data. And I have seen advanced architects do that for, I don't know, at least 10 years and maybe more. Take, for example, that cost model. That is something that I've seen, I think at least 10 years ago for the first time, using models to do these kinds of cost calculations. So yes, it is maybe partially just a new name for an existing concept, but given the increasing richness of data sources, for example, based on things like Internet of Things, all kinds of sensor data, all kinds of external sources that you can now easily integrate, I think that's where the main difference is with, let's say, classical enterprise architecture.
I think that's great. And one of my observations is digital twins is one of the buzzwords that are on top of the mind of many technology executives these days. And so an enterprise architecture, we know, has been around for many years. So recasting an enterprise architecture within the context of digital twin, some enterprise architecture teams get the attention with their technology leaders that perhaps they wouldn't if they just refer to this as enterprise architecture. So the next one is a little bit, I'm going to talk to you about this. So I'll read it directly. What is not clear to me is how do you mix a model with type?
Yeah, I think it might refer to how do you.
Yeah, let me finish it. So with operational data coming from instances, for example, Netherlands CRM application version 7, Spain CRM application. How do you intersect the live data coming from real live instances of applications with the concept of an application type?
Yeah, so if you want to use the real life instances, you should model those as well, and then just hang those data sources off of your real life instances. In modeling terms, you could, well, in Archimate, you could express that at different modeling levels. You could say, well, I have my high level application maybe in a functional way modeled as an application function, the application function customer relation management, for example. And then I have a number of implementations of that function in my different countries modeled as Archimate application components. That would be one way of doing that. There are a few other patterns that you could use. So there are ways of putting that in your model, but you're right, if your model is only at the type level, of course, then it's more difficult to put in data on instances. You need to do the data integration before that. Then you have to say integrate. In this case, maybe if you're talking about cost of systems, you might need to add up the cost of all the instances and hang that off your type. So it depends a bit. In some cases, you could just model the instances, put the data there. In other cases, you might need to do a bit of data aggregation before and put the aggregated data in your model. Yeah, depends on the specifics of your use case. But yeah, both cases are valid.
Got it. So in your travels around the world, Mark, is the next question here. Do you observe any particular industry which is leading this type of efforts? You referenced Tesla before, so maybe, you know, capital goods or something like that. But the observation is this sort of requires leadership.
Yeah, it's the digital twin concept in the technology world. That's really led by these high-tech companies like, well, aircraft manufacturing. Those are really advanced in that whole concept. Perhaps even the military is one of the sectors where they are most advanced in this idea. A digital twin of your enterprise, of course, is something different, and that's not really tied to specific sectors in my experience. The idea of adding all sorts of data sources to your architecture models doesn't depend on the sector you're in, but it does depend on the maturity of your architecture practice, because you do need to have some sort of solid model behind it. So it tends to be the more mature organizations doing enterprise architecture. And in general, I would say, but that's really generalizing, the financial services industry is probably the most mature in general in terms of enterprise architecture, because they've been doing it for quite a long time. Also because their operational processes are inside the IT systems. Whereas in manufacturing, they're now with the Industry 4.0 concept, they're doing a lot of this. There, the physical world is more dominant rather than the IT world. So that's a bit different, but I see digital twin concepts there in the physical world sort of gradually linked to the IT world as well. So that's maybe a bit different. But like I say, it's in general, it's not really about the sector, it's about the maturity of the discipline rather than specific sectors other than the high-tech world.
Got it. It's a good answer. Here's a great question, actually, and I was just reading this and struggling with myself to see. I'd be interested to know your answer, but you know, within the, and I'll add a little bit to this because I get a sense of where this is going. When you think of like an aeroplane or a helicopter or a ship, and you create a digital twin of it, the purpose of that digital twin is to try and predict future behavior of the system. How might it fail in the future? Does this approach within the context of enterprise architecture allow for future predictions?
Yes, in some areas certainly. One simple example, well, we talked about cost a lot. You can look at the evolution of cost of your application landscape. For example, one common issue in IT organizations is that the cost of maintaining your current state squeezes out all budget for innovation. You can look at the evolution of cost and predict based on what you see that maybe next year or in 2 years' time you won't have any budget left for changes. That's let's say for innovation. So you'll spend everything on keeping the lights on. That's a very basic case that you can easily make. So you can certainly do that. But it's not everything is predictable. But in this case, yes, you can. Also, if you link, say, customer data, say customer satisfaction scores, like I showed in this customer journey map, if you see customer satisfaction go down, and at the same time you see, say, the IT reliability go down, there might be a correlation that you might want to investigate. So you might do some predictions there as well. The one that was actually already a prediction, that was this red and pink one, where you saw the impact of the availability of IT systems on your business capabilities. So that effectively predicts how available your capabilities will be based on the underlying IT systems. And if you can see the evolution of that availability of the systems, you can predict the evolution of the business capability availability. So yes, you can do that in pretty much the same way you can do that for the physical world, although the properties in the physical world are often related to, say, fatigue, stress, and those kinds of things. So you might predict when an aircraft engine fails, or when a car needs, say, an oil change or whatever. Those properties are a bit different, but the idea behind it is still pretty much the same.
So what you're saying is historically we can correlate events with one another, for example, application availability with customer satisfaction. And then if we determine we need to do something to our architecture which might reduce availability, for example, or performance, we could reasonably conclude that we would anticipate a reduction in customer satisfaction in this period, because historically that has proven to be the case.
Exactly. It's all about correlating these data sets, using the models to, and then the models, you could say, it's not just the data that correlates, because you want to have you have to substantiate that there's a causal, that there's, let's say, cause and effect. So the causal link can be found through the models. If you see that there's a correlation between, say, application availability and customer satisfaction, if that data correlates, you can look in your model and see, oh yeah, indeed, this application is needed for that customer journey. And then you prove that there's indeed not just a correlation, but a cause and effect.
Perfect, that's great. We've got time for one more question. You again, we'll be sending out a link to the recording, slides, assessment, and what have you. The last question, which I'd like to see if you can sort of connect this to the digital twin assessment model we put together, Mark. But is there a maturity model for digital twin capability? And does that align to any other known capability maturity models, like presumably software development capability?
Yeah, well, there's no, let's say, widely known maturity model, but we have our own internal maturity model, which is, it has the typical 5 stages of maturity models you find elsewhere. That maturity model we use internally is based on and inspired by a series of existing maturity models, ranging from CMMI to the model behind COVID and some others. And we enhanced that with a number of other aspects like digital twin, also enterprise agility. And we keep that in one common maturity model, so that it's easy. Well, let's say easy. It's you can compare where you are across these different areas, because often these different aspects of maturity are correlated as well. If you're you can imagine if you want to be strong in certain areas, other areas correlate with that, and it's a bit strange to be very strong in one and very weak in another area. That's sort of a lopsided situation. So yeah, we have that maturity model. I don't have a download for you, but the DTO readiness check is based on that same maturity model. So the stages in that are the same.
So encourage everyone to look at that digital twin assessment. Mark, thank you for your time today. For everyone else, thank you for your time. If you'd like to learn more about BizDesign and how we help organizations like yours in your enterprise architecture practice, or indeed in your aspirations to become digital twin, please visit us at www.bizdesign.com. Links that are referenced in this presentation. Mark, once more, fantastic job. Thank you for your time today, Mark, and thank you for time for all people who joined us in this webinar today. Hope everyone has a great day. Thank you.